Question 5, consider the points A for -2 and B at -1, 1 as shown on the plane. Which expressions are algebraically equivalent to the correct use of the distance formula to find the distance between A and B? There's more than one correct answer choice. Select all correct answer choices. Okay, so if you go back and you remember the distance formula, we have it algebraically and we have it contextually. So why could there be more than one equivalent expression? And the reason is because you can label each point differently based on which one is x1 and x2. So let's just use this one since it's starting out with the algebraic equivalence. Even though they're giving us a grid, they want it algebraically, so I'm not going to use this contextual representation of that formula. We're going to use our algebraic one. So again, if I label point A as the starting point, then 4 would be representative of x1 and -2 would be representative of y1, and B would be the ending point. So it would be and -1 would be representative of x2 and 1 would be representative of y2. So then if we use this formula and we said, okay, well, by substitution x2 is -1 and x1 is 4. That's how we would start it off, and y2 is representing 1. And y1 is being represented by -2. So we would be looking for a distance formula with -1 minus 4 squared to match with this one. So we have a -1 minus 4 squared plus 1 minus parentheses -2 parentheses squared. That's okay that they included those parentheses around this -2. They're just saying that that negative belongs to the 2. So that is one way. The other way is, well, what if we said A was our ending point and B was our starting point? So they would have labeled B as our starting point, which is x1, representing a -1, and y1 representing 1. And if A is our ending point, then 4 would be representing our x2, and -2 would be representing our y2. So the formula would be then x2 is being represented by 4, and x1 is being represented by -1. They will most likely include parentheses around that just to indicate that that negative sign belongs to the 1. y2 is representative of -2 right here, and y1 is being represented by 1. So now we're going to be looking for a formula of 4 minus a -1, 4 minus a -1 squared plus -2 minus 1 squared. That matches our expression. Now I'm thinking to myself, okay, is there anything else or any other way that there would be equivalent expressions if we were to look based off of these two that we have found? And I'm scanning and I'm noticing that we have the 4 minus -2, which is not correct. We have a 1 minus a -2 plus a -1 minus a 4 squared, and I'm thinking to myself, okay, that looks kind of familiar, except they picked up this last piece and moved it to the front, and this piece was moved to the back. Is that legal? Yes, it is. So if you were to apply the commutative property, that would swap So based on the commutative property, if we were just to take this, it would pick up the first place and it would move it to the end. So commutative property means it swaps it. So yes, this is also an equivalent expression. And so if they're using that for the first one, then I'm going to ask myself, well, are they using it for the second one? And more than likely that is true. So I'm going to first just use the commutative property, which means you switch them places. So we have this, and now we would have this. Oh, whoa. Okay, so now I'm going to be looking for a -2 minus 1 squared, which I pick up right here, plus a 4 minus a -1 squared. So yes, that is also equivalent, and notice it's just the commutative property of this one again. So I hope that helps.